So systems of linear equations, that's kind of the more title, and that's really kind of what we're doing. And want to say 2 bullet points. Like when they talk about systems of linear equations, what in the world are they talking about? Well, first of all, the system is going to have 2. So it's basically 2 lines. Why don't we just say that? 2 lines. Because a linear equation is going to be an equation for a line, right? Linear is line. So a system is going to be 2 lines, and I wrote 2 twice, didn't I? So 2 lines that are considered together. So considered together. And we'll look at a couple examples of this soon. So 2 lines that are considered together. And when we have that, if the lines cross, that point is the solution. So when you have a system of linear equations that has a solution, the solution is going to be where the 2 lines meet. So if the 2 lines cross, you could say that point, or the intersection is more the math term for it. The intersection is the solution to the system. Kind of why? Well, if you have an equation, if you have an equation for a line, that line is going to be all the points, all the xy pairs that work in that equation. So if you have one line then that looks like this, that's going to be all those points on that line are going to work for that equation. Well, if I have a second line, now where those 2 lines meet, so this spot here where they cross, that point, that x and y value, that pair is going to work for that first green line that's going up and to the right, and it's going to work for the second green line that's going down as it goes to the right. So that's going to be the point that works for both equations. So that point works in both equations. Yesterday when we were looking at we did that Explore thing yesterday. We had the Ray's boat rental and the Vista's boat rental. One of the questions was, what's the point that it costs the same for both places? So at what point does it not matter which boat rental you do, the cost is the same? And that'd be kind of like this here. We looked at a data table, but if you look at the lines, where those 2 lines meet, that's going to be, for that x value, that amount of time, the y value is the same. You could, if you wanted to, I took a picture of it, but if you wanted to, you could flip to page 201. If you do, you basically see a little clearer version of this. This is a little bit blurry. But I thought I just would point out a couple examples in the book as opposed to trying to write all new examples. But this one here, they're looking at going to a carnival, and you could either pay $10 to get in and then $1 for each ride, or $6 to get in and $2 for each ride. And they're trying to say, well, for how many rides is it where it's going to cost the same amount? So it's kind of like our boat rental one from yesterday. Well, you could, for this, they go and they try to solve it as a data table. So I'll get my little pointer thing. So here's our equation for the first one. So the $10 to get in and then $1 for each ride. So 0 rides cost $10, 1 ride is 11, 2 rides is 12, 3 rides is 13, and so on. Our second one was $6 to get in, $2 per ride. So then 0 rides cost you $6, and then 8 for 1 ride, and so on. So the point that they're trying to make then is you break even right there. When x is 4, when you have 4 rides, then it costs you $14 no matter which package you do. Good? So less than 4 rides, that bottom row is going to be cheaper, the $6 to get in, and then $2 per ride. If you're going to do more than 4 rides, then you should do the $10 to get in and $1 a ride. That's where that one would be cheaper. Good? If we graph this, the line for that first equation, the line for the second equation, they'd cross at the point 4, 14. Good? And then the second example, so across the page if you're in your book, they do that same sort of thing, except for now instead of giving you the data table, they give you a graph. And it's hang gliding. Basically they're saying for hang gliding, is it cheaper to rent equipment each time you go, or is it cheaper just to buy your own equipment and then go? So they give us that, okay, well, you could pay $70 per flight if you rent equipment, or you could pay $200 for equipment, and then they only charge you $25 for each time you go up. And where those two lines meet is at the 4,300. So for an X value of 4, so when you're over here, so when you have an X value of 4, when you have 4 hang gliding flights, it's going to cost you $300 whether you rent or whether you buy. Fair enough? So sometimes the data tables are nicer. Sometimes the graphs are nicer. If you have it where they meet at a nice point, then the data tables are probably going to be easier. So like this here, if you punch this into a graphing calculator, 414 is going to show up in your data tables. If you have your second one, okay, I take it back. The second one would probably also show up in the data table nicely. But if you ended up with like decimal answers, they cross at like 3.4, you're not going to see that in a data table. So that's where the data table wouldn't work as well.